Okay, if you're ready, you may start now.
Hello everyone, today we will talk about 5-story building. And this slide is a property of member. We use 5 meters in length and 3 meters in height. And the material we use a steel in my fraction. For the top part is the pin. Light load equal 300, super dead load is 100. Concrete slab load is 350. And from a member side, in beam from the outside, we use it lower than inside, and the column we use it outside and inside is the same section. And this slide is a detail in the steel. This slide is a detail for column side and beam side. And we use it load pattern is dead, super dead load and light load. And for the load combination is a dead part light. And for result.
For reaction force in YC plane, the maximum reaction force of outside is 189 tons, and inside is 103 tons. In XC plane, the maximum reaction force of outside is 189 tons, same as the YC plane, and inside is 106 tons. For bending moment in YC plane, the maximum moment of outside is 6.46 tons meter, and inside is 8.78 tons meter. In XC plane, the maximum moment of outside is 1.95 tons meter, and inside is 2.63 tons meter.
For the shear in XC plane, the maximum shear is the 1,166 kilogram, and shear in XC plane in inside plane, the shear maximum is 976 kilogram. Shear in YC plane in outside, the shear maximum is the 5,961.51, and shear in YC plane inside plane, shear maximum is 10,663 kilogram. For the deformation, we see that the critical plane is at the YC plane. That can see in the picture at the edge. The value of deformation UT is minus 0.0041 meter. And this is the steel section check. As SAP 2000, it can check the steel design and can see the problem at the green line. That is the critical at YC plane. And this is the steel section check data that at the column 8, and check about moment and shear and axial force, and that is okay for the structure. So this is our presentation. Thank you for your attention.
Okay, you may start now if you're ready.
Okay, today we present about 5-story building project. Next. This is the name of our group member. Next. For the information, we design the 5-story building concrete. A 5-story concrete building in 5 multiplied 5 meter for each bay of X and Y axis, and the story height is 4 meter. We should pin for the support. For the load to analyze which are right loads and superimposed loads are 300 kg per square meter and 100 kg per square meter respectively, and the concrete slab thickness in this side is 15 centimeter. Next.
Okay, for the material in this project that we use, for the first, we use the concrete 280 KC, and for the steel bar, we use SD40 and SR24. For the property in this project, for the column, we use column 25 multiplied 25 centimeter and 30 multiplied 30 and 40 multiplied 30 40, sorry. And for the beam, we use the beam 20 multiplied 40 centimeter. For the load combination in this building, we use the SD design and use the load combination is 1.4 dead load plus 1.7 live load. For the dead load plus live load that we use in this project, we use to check the deformation. Okay.
What's next?
Napat.
Sorry. And this is the deformation shape of our buildings. And next is the actual force diagram of our buildings. And next is the force diagram. And the last one is bending moment diagram. Because of our building is symmetry in every floor and both sides, so it's these three diagrams look similarly in every story, every room. And next is slab shear. The hot tones, the hot tone color, it shows the negative values, and the cold tone colors, it shows the positive. With the yellow, it means 0. The scale applies in the slab moment to which the The deepest blue, it's mean the positive.
So next is the detail of our column and beam. Firstly, we use all the same side of the column for all of our building, but we found that there is some problem because the column at the middle has very high the ratio between the reinforcing steel and the concrete. So we need to change the side of the column. So finally, we got 3 sides of column, that is 40 times 40 and 30 times 30 and 25 times 25. So in this detail, it tells us that the actual force or the compression force that act on the column, including the moment and the shear force. So for the detail, we will focus on the area of the rebar. For the 40 times 40 column, the area needs is 0.002 meter square. For the 30 times 30 next, the area need is 9 to the power of minus 4 meter square. And for 25, it needs 6.25 power of minus 4 meter square. So you see that when the side of the column is increased, the area of the rebar is also increased because we choose the small section of column to subjected to the lower load. And next is the beam. Beam detail, we choose 20 times 40. The detail show the negative moment and the positive moment. And if you want to know where is the negative and positive moment, you can see it in the bending moment diagram from previous slide. The rebar need, it show both top and bottom axis. The result show both negative moment and positive moment, including the minimum rebar area need. So it show the summary of the top and bottom required rebar area. So the result at the top is 7.28 to the power of minus 4. For the bottom is 4.1 power of minus 4. So that's it สิ้นสุดการนำเสนอครับ
Okay. If you're ready, you may start now.
Okay ค่ะ Good morning class of CVE 448 อาจารย์ชัยนรงค์ and my dear classmates. Today we are due. Let's jump right in. First of all, I'd like to give you an overview of our building design. Our building consists of 5 stories, 5 bay in x-axis and 3 bay in y-axis. The height of each story is 5 meters and the length of bays are 6 meters, 300 kilogram per square meter of live load and 100 kilogram per square meters of superimposed dead load are distributed. All supports are fixed and 15 centimeter of concrete slab thickness is used. Moreover, the building was designed and analyzed by using ETABS.
Okay, for the materials of this building, we use 240 kilogram per square centimeters compressive strength. And for the steel grade, we use SD40 and 24 steels. These materials are used and construct for all reinforced concrete sections. And for the cross-section areas, the dimension of 30 times 50 centimeters is used for the beam, and 40 times 40 is used for the column. All in all, the building was constructed by using the materials and the criteria as present. The building passes the design check. Here is the section of the beam as shown in the slide. And here is the column. Now we'll shift to the discussion part. The first one is the local axis and the discretization. There are line elements and which are column and beam. We need to concern the local axis and direction of the element as the purpose of correct state sign convention as same as the area of element, which is called a diaphragm. The areas need to be constructed anti-clockwise for positive sign convention. And the next is relationship between the stiffness, depth of the beam and the displacement. As the stiffness of the beam is inversely proportional to the deflection of the beam, which leads to the increasing moment of the column. Therefore, we should use big beams with small columns and vice versa.
Okay, what is the appropriate depth of the beam? As we know that when we increase the depth of the beam, the moment capacity is increased. In the other hand, the self-weight of the beam will be increased also. That the strength of material should be enough. After we tried an error, and we found that the depth of the beam should be L over 18, which L is the span length, which is the appropriate depth or minimum, okay, for the both continuous beam, okay. And the usable area are increased when we use the appropriate depth or minimum depth, okay. And however, it should not be less than 0.35 meters of depth because the beam will not able to resist the moment and lead to the longer beam, which is unsuitable as it called the last deflection, okay. And next, why are the fixed supports is used? As the concrete is used in design, fixed supports are used for entire building because characteristics of the concrete are similar to the rigid joint, which is unmovable or unrotated. On the other hand, for the steel, nuts are used. Therefore, steel are movable or rotated. Okay, why we choose pin joint for the steel structure. Okay, for the safety factor for torsion. Okay, in order to prevent the failure due to the torsion as the critical section, the safety factors are used for the moment of inertia, or we call the effective moment of inertia, as the torsion is the most due to the value of the moment of inertia. Moreover, the failure due to the torsion at the column are really hard to occur. Therefore, the safety factor or effective moment of inertia is 0.35 I for use for the beam, and 0.7 is used for the column. Okay. Next.
So, sorry, thank you, Kubin Pop. So, next we will discuss about the story height and the length of bed that we use. Actually, we have built many models in comparison with this one, but according to the height and the length that we use, we select the suitable length and height by using the ratio of area and the total reaction. And all in all, 5 meters of the height and 6 meters of the length are used, as the area acquired is worth the construction the most, and the building is easy to be constructed as well. So let's summarize what we have discussed today. So we have used the ETAP software to design the building, and the design building satisfy all load conditions. And also it follows the standard of ACI 31814, the reinforced concrete design. And in fact, the finite element concept was applied to analyze and build this building, because the direction of the member or the local axis is compared to the global axis of all structural members. So here is the end of our presentation, and thank you for your attention. If you have any question, please feel free to ask.